everyone. Brave people doing a code talk after lunch. My name is Danny. I'm a solutions architect. I'm focused on Gen AI. I work in the Amazon Bedrock team, focusing on knowledge bases and agent core memory. And I'm here today with Akarsha. Akarsha, do you want to?
Hi, everyone. My name is Akarsha Sehwag. I'm a Gen AI data scientist with agent core memory team.
Yeah. So today, let me just go back a second. What we're going to be we're going to be doing a code talk. So it's going to be basically us going through some code. So it's going to be like a level 400 session. So we'll dive deep into the details of the different APIs and the code that we're going to be using today. So we're going to be diving deep into agentic RAG systems, right? So we'll just start out. We'll set the layers, so the foundation. Let's talk about what agentic RAG is. And then we'll see what we're building today. And then I promise I'll go out of the slides and go into the code, right? I won't be an hour with slides. And at the end, we'll give you some resources that we put together to get started. So let's start with the basics. Retrieval augmented generation. I hope everyone in the room has heard about this. We've been talking about this for the past 2-3 years. So I just want to go quickly over what retrieval augmented generation is, right? Or how the workflow goes. At the very, very high level, we have our query that we send into our model, right? But before we send that into a model, we're going to augment that query, right? We're going to give it additional information. This can come from our internal data sources, or you just want to provide external information to the model so it doesn't hallucinate. And then it will have the full context to generate an answer and give you back the response. But Akarsha, is that correct or not?
I mean, it's partially correct.
Yeah.
So when we think about agents, right, we have the LLM that has a lot of capabilities, but agents themselves are fundamentally stateless. So all we can provide from our side to make them better, to make them smarter, is in this retrieval, in this RAG component. So today, we don't just consider RAG to be retrieving from a knowledge base or a data source. We talk about more in a generalized way, which is called context. So today you must have heard this new term popping up everywhere, which is called context engineering. So essentially what it does and what it means is we are curating our context in a way that we are providing very precise information that the agent needs to give smart and more accurate responses. Right? So that includes information from the documents, so the traditional RAG component. Then it also includes curating our tools, so figuring out which tools are relevant for this current query or this current use case, so finalizing those, and also making sure that whatever information we have provided in those tools is very accurate for the agent to know when to use it. And then we have the memory component. So memory component is where we are providing it with more information about the user to make it more personalized, to make the experience for the user much better, right? So that's where the memory component comes in. And all of this combined is what defines the context.
Yeah, that sounds right. So now we have all this context coming in, and we have a new way of retrieving our information, right? So we have our query, we'll have a retrieval. That retrieval can, import information from different sources, as Akarsha just mentioned. Then we'll augment that query, and then the model will decide, hey, am I able to answer with the information I retrieved, or do I have to go back again and look for a bit more information? If not, we can get back the response. Apologies. So this is agentic RAG at a high level. Apologies. So what are we building today? Okay, why are we here today? We are going to be building an event agent. Okay, as I imagine, you have your AWS events application right now, and at the bottom I saw before there was a small text box which said, "So ask me something" or something like that, right? And you'll have your common agent now, or your common chatbot implemented into all of these applications. But we want to not only be able to search across the sessions information, but we want to deliver a truly hyper-personalized experience to our users, right? So I can say, hey, what sessions do you recommend me? And I expect, or we normally expect nowadays, these agents to have information about us, right? Remember some stuff about us, and being able to recommend the stuff based on our preferences, right? Or questions like, which session did we talk about last time, right? Having some kind of history, or what sessions are there on Monday, right? These kind of common event questions that show up, and if you don't ask the app, you ask someone who's there to help. We wanted to have it all in a single place. So we're going to be building this awesome event agent, okay? And this is going to be basically an agent that has two capabilities. So our users are going to be able to interact with our agent, and that agent is going to be able to do two things. One of them is, as I mentioned before, retrieve session information from a knowledge base. And secondly, it's going to be able to store and retrieve the conversation history that we had, right? And it's going to be able to learn from our conversation, our user preferences. Okay, so yeah, I think that's enough slides at the moment. Let me go and show you how this looks from a code perspective. If there are any questions, put your hand up. It's a small room today. We'll try to answer the questions along. If not, we are happy to answer the questions also when we are outside, right? Mm-hmm. Cool. So, I'll go through I've got the notebook ready with this event agent. We'll make this available this week in our repo for agile samples. We'll give you the resources for that later. So just bear with me and let's figure out what's going on in this notebook, okay? So can everyone see this right? Let me just go to the text and see if we need to make it a bit bigger or not.
Yeah, okay, good.
Good?
Yeah.
I don't see anything because I've got these big lights here. But anyway, so this was the same slide as before. This is the high-level picture of what we are building today. And we're going to go through what we call different chapters. And it's going to be creating the agent. We create a simple agent. We create the knowledge base. That's where the session information is. We create the memory for our agent to have that persistence. And then we're going to see how we can move this to production and do it in a secure way using Agent Core Runtime or Agent Core Identity. So if I start here with my notebook, pretty simple, just installing some dependencies. I need this to work with. I'll import some libraries that I need for the notebook to work. And important things here is that I'm going to be using Cloud Haiku 4.5. I'm going to be using Amazon Titan Text Embeddings v2 for my knowledge base, and I'll talk about that a bit later. I just want you to understand what's going on here. I'm just setting those. I'm creating a unique ID to have unique resources. Okay, pretty simple. For every code cell, I will show you the outputs. It makes much more sense. So let's start with the agent. What are we going to, yeah. Sorry,
we'll get to that.
Yeah, give me one chapter and I'll get to that. So let's start with the agent, right? Let's start with the most simple step. We're going to be building a simple agent, right? And that agent is going to have a context. And that context is just going to be you are an intelligent event assistant, right? So I'm going to be using Strands agents. Akarsha, would you use any other framework here? Or?
You can use any framework you want. So you can use LangGraph, LangChain, CrewAI, any framework that you're currently using. We use Strands agents because it makes it very easy for us to build agents. And Strands agents is I would say, fairly new framework that has been out in the market. It's an open source framework that allows us to leverage the capabilities of the model itself to be able to plan, to take actions, and also to revisit whatever has occurred, if it actually achieves the goal or not, to be able to reflect on that.
Mm-hmm. Okay, then I'll go with Strands. So what do I need to do to create my agent with Strands? I'll just import my agent class, and I'll import my model class. I'm going to be using a model, which is available on Amazon Bedrock. That's the Haiku 4.5, right? And to create an agent with Strands agents, it's as simple as, let me just get my pointer out here. I'm going to create my simple agent. This is going to be my class that I wrote before. I'm going to be defining a model, the model that's underneath this agent, and I'm going to be giving it a system prompt, right? So I'm going to give it a bit of context on what it's supposed to be doing. So it's as simple as saying, hey, you're an intelligent event assistant, okay? Simple as that. You create your first agent, one line of code if I take out the white space. So when I go and interact with this agent, I'll say, hey, simple agent, which is a good session to learn about security and AI agents, right? And we'll see that the agent will respond, hey, I don't have enough information about specific sessions or events in your current context. And that makes completely sense because I haven't told it I'm at reInvent. I haven't given it any information about the sessions. It's just a blank agent, and it's just using the model under the hood with the information that it's been trained on. So that's completely normal, right? So how do we start giving context to our agent? So one way is via knowledge bases, right? And with knowledge bases, what we're going to be doing is we're going to be providing the reInvent. So in this case, I'm using the reInvent 2024 sessions I found around. And I'm going to be providing that to my agent. Okay, so for anyone who doesn't know in the room, Amazon Bedrock Knowledge Bases is a fully managed service inside Amazon Bedrock, and it helps you create fully managed workflows for RAG, right? So we are going to be able to create a knowledge base where we are going to say, we're going to be able to define our data source layer and a data storage layer, right? So when I'm talking about data source layer, I have right now in GA, we have 2 available data connectors, so I can basically bring in my data from S3, or I can directly send in the information into the Bedrock knowledge base. I have 4 different chunking strategies, right? So when we're talking about RAG, the flow is normally you have your documents, you get those documents and you parse them to understand what's inside those documents, right? And once you have that, you're going to split those documents into smaller chunks, okay? Then using an embeddings model, we're going to transform those chunks into vectors, and those vectors end up in a vector database, right? Pretty simple RAG. Knowledge bases helps you with this whole process in a managed way, right? You only have to configure where your data is coming from, what kind of chunking strategy you want to use, what kind of parsing strategy you want to use, and then define what embeddings model I'm using and the underlying vector store. Okay, so all that information is going to end up in my knowledge base, and then I can use retrieve API to retrieve the chunks. So we're basically doing a semantic search against the vector database. Or I can use retrieve and generate, which will combine that process of retrieving my chunks and automatically sending it to the foundation model, right, and getting back a response. So I have those 2 options there. So what am I going to be doing? I'm going to be creating a tool for my agent, and that tool is going to be able to call knowledge bases. Okay, so here in my code, let me see, I'm going with time, I'm going good. What I'll do is, these are the steps that I'm going to go through. I'm going to download my 2024 session data. I'm going to create my S3 bucket, that's where those documents are going to end up, and I'm going to upload them. I'm going to create an S3 vector store and index. So for this use case, I'm going to be using S3 vectors, right? This is a fairly new capability from S3, which gives support for vector storage, okay? Then I'm going to go and create my knowledge base and do the ingestion job, okay? Finally, I will test that knowledge base, and then I will create that tool for the agent to consume. So pretty simple steps here. I don't want to spend too much time on this. The other one is more catchy, I think. But basically here, first step, what I'm doing is I'm basically downloading my data, right? I'm downloading, it's basically a single file which contains information about 583, if I remember correctly, sessions.
38.
Exactly. It downloads that file, and I'm just understanding what's going on that file. Then I'll prepare those documents. So instead of having a single file, I'm going to split it across 580 different files which will go into the knowledge base. So that's just basically what I'm doing here, right? I'm creating my directory, and I'll split that single file into multiple files. Okay, pretty simple. So I'm going to be preparing those documents, as you can see here, creating those 500 documents and putting it into a folder. Then what I'm going to do is I'm going to send those documents to my S3 bucket. Okay. So here I'm just creating my S3 bucket. I'm going to give it a unique name. That's where I'm going to be sending my files to. And once I have created that bucket, I will upload the documents, right? In this case, we're using Boto3 to send the documents to the bucket. Pretty simple. Right, so as you can see here, I'm creating my bucket, and then I'm uploading all the files. This took like this took 1 minute. It's okay. It's not that much. Next, what do I need to do? I need to create my IAM role for my knowledge base, right? My knowledge base needs access to an embeddings model, and it needs access to the S3 bucket, right, in order to do all of its tasks. So I'm just creating a simple IAM role where I'm going to be creating it, and I'll use it later, okay? All of this, we can do it via code, which is what I'm doing right now, but you can also do this via the console, right? Maybe a bit nicer. But I have my notebook here. So just creating my knowledge base role there, pretty simple. And then I'll go and create my S3 vector store and index, right? This is where knowledge bases is going to do the whole ingestion job, and the resulting vectors from the chunks that we created, they're going to end up in that vector store. Okay, and it's as simple as saying, hey, S3 vectors, I'm using the Boto3 client for S3 vectors, create the vector bucket, and I give it a name, easy. And then I go and create vector index. Okay, so here in the vector index, what I'm saying is I'm going to give it, where it's supposed to be, that index in the vector bucket I created before. I'm going to give it an index name, and I'm going to give it a dimension, right? And this dimension that I'm using here, which is 1024, I'm stating that there because that's what Titan Embeddings v2 is going to be giving us back when we do that conversion from text to embeddings, right? Then we set other topics like distance metric, data type, and some metadata configuration. Okay. So here we're just creating our S3 vector store and index. As you can see here, we'll get an ARN for both of them. And now I can go ahead and create my knowledge base. Okay, so I'm creating my knowledge base, simple API call. I'm creating my knowledge base here. I'll use my pointer better. I'm creating my knowledge base, giving it a name, I'm giving it a description. So it's my AWS re:Invent 2024 sessions knowledge base, and giving it the role that I created before. And then I'm filling in the configuration for that knowledge base, right? So basically here what I'm doing is I'm saying you're going to be using the Titan Text v2 embeddings models that I defined at the start of the session. And this is the configuration for that embedding model. Okay, here's the 1024 that I used before for my index. Okay, and then for my storage configuration, it's going to be using that index store that I set up before. Pretty simple. Any questions up to here? I explained it very good, or I confused you even more? Okay, I'll take it as the first one. So I just created my knowledge base. Now I can go ahead and import and ingest the data from S3, right? So I created my knowledge base, and I'll go and ingest my data. I'll create my knowledge source. It's an S3 type knowledge source, data source, sorry. With my S3 configuration, I'm giving it my bucket name. And here I'm giving the chunking configuration. I'm using a fixed size strategy. We have fixed size. We have no chunking. We can do semantic chunking. We can do hierarchical chunking. You can even bring your own Lambda to do your own chunking configuration, right? So there's quite a lot of flexibility there, depending on your use case. Okay, but in this case, pretty simple, fixed size, max 300 tokens. And then 20% overlap, 20 token overlap percentage. Right, so from there I can go and start ingesting my data, and I'll wait for that to finish. That took me around 2 minutes. That's good. It processed my 583 files, and I can go ahead and test my knowledge base retrieval, right? So if I ask a question, hey, what are the sessions about generative AI and security? I will go and use the retrieve API, which I mentioned before. So I'm just retrieving the chunks. I'm just doing a semantic search, and it will give me back the 3 most relevant results for that query, right? So if I ask that question, it will say, hey, I found these 3 results, and these are the 3 chunks it got back, right? These 3 sessions that I have here, okay? Pretty simple. I just created a knowledge base, ingested my data, and I did that all programmatically. Now, fun bit, I'm going to create my knowledge base search tool, and this is what the agent is going to be using. So how tool works with strands is that you're going to take your Python code with your typical function, and you're going to put in here this tool decorator, okay? And with that tool decorator, then you can pass it on to the agent, and the agent will make use of that tool. So the nice thing about this tool is that I'm going to be passing in description, and that's what the agent is going to first read, right, and see if it needs to use that tool or not for the task it needs. So as you can see here, I'm saying, hey, this is a tool to search reinvent sessions from a knowledge base using semantic search. Use this tool whenever a user asks for a recommendation about reinvent sessions, right, and I can pass in a query and the max results. Right? And this is just a plain API call to Bedrock knowledge bases, which is retrieve. Okay, and I'm passing in my knowledge base ID, my retrieval query, and my retrieval configuration. Okay, so with that, I have my knowledge base search tool created. And I think, Akarsha, you can take it on from here. Yeah.
Okay, so we have one of the components of the agentic RAG that we were talking about. We have that ready. And we have that ready for consumption as well, because we have created it as a tool, right? So one key difference why you would use something as a tool would be when you want the agent to decide. You want to have it the flexibility to choose when does it want to call it, when does it feel it's relevant to call the knowledge base, right? So that's when we are using the tool. We could take another approach with the hooks. This is what we are going to see a bit later here. But it's dependent on how dynamic or how deterministic do you want it to be. You would choose one or the other. So now let's add the second component of RAG, of context, into our agent. So let's look at the memory, right? So what memory does to persist our agent conversation. So we added the RAG so far with some generic information, right? Now we are adding memory to have more personalized context about the users. So how that works is our users, when they're interacting with the agent, they have this conversation that they build up over time, right? So that information goes into agent core memory as events. So those events we term as short-term memory. Those events we send into short-term memory, which stores those events into a data store as raw conversational messages. Now those messages, based on how you configure it, so you can choose to have more extracted insights from those events and say that, for example, hey, I want to create user preferences strategy. So I want to extract from all the conversations you've had, I want to extract user preferences from that conversation. Or you can choose something between semantic or summary. So these are some predefined strategies that we have in agent core memory. Or you can customize those as well. So you can either customize the prompts of those inbuilt strategies or create a completely new pipeline of your own. So that's completely dependent on you.
Yeah, and if I can just add on to that just for a second, just to give you a use case, right? We have our agent, which we are speaking with for a whole week. If I'm stacking up the conversation history of over a week and sending it over to the agent and for the LLM to process, whoever's paying for the bill is not going to be happy because you have this really big context and it's going to be affecting the price because it's a huge context. It's going to be affecting the latency because it's got to process more, and then it can even have problems with accuracy, right? If I've got this huge amount of information I have to process, it's it should be better if it was smaller, right? So instead of taking that big context and passing it onto the agent, it makes more sense to extract what's actually important from that conversation, right? And that's where the long term comes in, where you're defining, hey, from all of these messages that are going in between my users and my agent, I want to extract specific things. So I can extract user preferences, semantic facts, session summaries, or you can even find your own, workflow of what you want to extract. And I'll shut up with that.
Yeah. And
question here.
Yeah.
For the short-term memory, what use an LLM to decide what is relevant based on the context?
for the short-term memory, you store deterministically. You send those messages in the agent core memory. So there.
Which ones would I send? Like if I have a conversation history of like 10.
Ideally, you send all of them.
Oh, yeah.
Okay.
Sorry.
Yeah,
Sorry about that. Yeah.
So is this based on the session of the user, like this short-term, long-term memory shared between multiple users, like how you chunk this?
So agent core memory is defining the separation based on the actor ID, the session ID, and the memory ID. So when you're creating a memory, it takes in two more identifiers from you, which is the actor ID and the session ID. So the actor is usually the user, but it doesn't have to be. So it takes in a string that defines who do these memories belong to, right?
Okay.
So it can be the agent, it can be a project, it can be a team, it can be a combination of these. You have flexibility of what you want to define in that actor ID, and same for session ID. But those would be the identifiers based on which it will separate the memories one from the other. Yeah.
So one, for example, take the feedback that the user has given on the sessions that they have attended when they fill the survey.
Yeah.
We hope for this session it's a 5-star. I just saying.
So to give recommendations on the next days when they ask, would that be a memory? Would that be another tool?
That should be stored in the memory.
This will be
That should be in the memory, yes.
Yeah, we'll get to that.
We will
We'll
look
get
at
to
the
that.
code.
Yeah.
So I think code should clarify how to use it, but this is just more on the conceptual level right now. Should we proceed? Yeah.
One last question. Still not getting a hang of it, to be honest, probably because kind of more the context, the better the accuracy, the latency sucks.
Right. So you're storing everything into Dynamo,
Yes.
and then when you have to get back, information, you're getting back everything that's from Dynamo, right? That Dynamo would be corresponding the short-term memory, right? But what the first of all, this is a managed service, so you don't have to focus on building a memory storage solution. We give that for you, taking care of infrastructure, scale, and all the other things that normally come with managed services with AWS. But then we don't stop there. We don't stop at that Dynamo that you're building.
This should come.
Yeah.
long term.
Sorry?
This we will explain in the long
Okay, yeah, I'll let Akash explain it. Yeah, I'll let it say what comes after.
I think we will explain with the long term of what you're describing. So maybe that helps.
It will make
if
sense.
not, then we can take this question again.
Yeah.
All right. Okay. So based on how you've configured the memory when you created the resource, you can define one or more strategies for smart insight extraction, right? And you can define one or more of these strategies: summary, semantic, or user preferences, or create your own. And based on that, it goes through an extraction module. So it goes through an extraction pipeline, which essentially consists of two steps. So one is the extraction step, which is going to look at all the conversation and extract only the relevant piece of information. So for example, if you're talking about user preferences, not everything that the user talks about is talking about user preferences, right? So from all of that context, it's going to only retrieve wherever a user mentions something that they prefer, they like, they dislike, or whatever they prefer. So it only extracts that information. Now, the second step in this extraction module is the consolidation step. So now it looks at the existing vector store, so whatever memories it has existing about that user. It looks at those, retrieves the most similar ones, and it compares the new memories that it has tried to create and the existing memories. And based on that, it consolidates that and takes one of the steps. So it either can add a new memory into the vector store, or it can update an existing memory with more complete piece of information. Or the third one, if it's redundant, if it's not adding any new piece of information, then it just skips it. So this way, we do not have any duplication in the memory store that we create. So once those memories are ready, we save them into the long-term memory store, which essentially is a vector store from which you can semantically retrieve the similar memories as and when the user asks something similar from the agent. So you can retrieve the long-term memories, which are more extracted insights, but you can also retrieve the raw events. So you can list, let's say, the last 5 messages from that particular session, plus perhaps the summary of that session to compress the context so that we do not have to deal with the entire conversation window. The entire context window. So we can make our agent more
aware.
Yes.
Speaking to.
All right. So how do we do that? So with strands, first of all, we create a memory manager, which provides us with the control plane API, where we can call get or create memory. And we provide in a name of the memory and the strategy that we want to create. So these strategies, we don't always have to provide one, but we can provide no or more strategies that we can add in here. So it takes in a list of a dictionary, which takes in what type, what strategy type do you want to define, what namespace do you want to have. So namespace in this case is going to take in a path-like structure, which allows you to create that separation of concern in the long term. So in short term, we did that by actor ID and session ID. In long term, we are going to do that by namespaces. So here, based on how granular or how global do you want your memories to be, you can define a longer path with more variables. So you can add you can add 0 or more of these variables. So you can add actor ID, you can add a strategy ID, or you can add a session ID as well. So based on that, it'll create a path for you, which you can then retrieve from.
Yeah. So basically, instead of just having a very big vector database where you just throw in the new memories that are being generated automatically, you're able to create your own separation. You create your own structure on how you're saving those memories, so that when you have to go and retrieve those memories, you have it in a logical way.
Yeah. And then you can define also an event expiry day, which defines how long do you want the short-term memory to stay. And so in this case, it can be anything between 7 days to 365 days. And then you call that API that returns you back with a memory ID. Right? So this memory ID now you can store somewhere and kind of use it to every time you want to store the memory information for your users. So it takes on about 1 to 2 minutes.
Yeah, imagine you'll have your agent, and you will have you have your agent, and you have your memory resource. That agent will have to write those events to those memory to that memory resource, right? So you have that memory ID, you have your actor ID, and you have your session ID, and you just have to send information over to agent core memory.
Exactly.
And I won't say anything else.
Okay. You should. All right. So how do we add that to the agent, right? So we have created a memory resource. Now how do we write to that? So first approach was a tool approach that we saw for RAG. The second approach that I was talking about was hooks, right? Here we are taking control of different parts of the agent lifecycle. So how it does is it enables us to write or to take an action at different points of the agentic lifecycle, meaning I can define that whenever the agent is initialized, for example, run a certain action, right? So I can hook something in that part of the agent lifecycle. So I can say every time the agent is initialized, call the agent initialized event, right? Similarly, whenever the user sends a request, call the message added event. So this is then another hook that you can add. So we are going to use this capability, which you can hook at different points in time. So when the tool is being called or when the request ends, so when the agent responds back. So we are going to use 2 of these hooks to create and to add our memory and to retrieve from our memory. So how does it look like? So what we do here is, first of all, whenever the agent is being initialized, we are asking our agent to retrieve the user preferences from the long-term memory. So every time the agent is initialized, we essentially load a profile of the user to know what their preferences are, right? And then every time a new message is added, we are storing the message that the user sent and also the messages that the agent has sent to our short-term memory. Now, behind the scenes, it should automatically propagate to long-term memory, so you don't have to do anything there. But that's how we'll do. And the second aspect was we already created a tool for the session data retrieval, which was the RAG aspect. So that's what we are doing for retrieving the event information from knowledge bases. So now let's see that. So here we are creating a class called Memory Hook Provider, which inherits from the Hook Provider class provided by Strands agents. So here what we do is we're defining mainly 2 functions. One is on agent initialized. So here I say that whenever the agent is initialized, search the long-term memories from this namespace. So this was a namespace that I defined when I created the memory. And with this query, so this way it can find similar information. So I already hard code that, hey, give me the user preferences, interests, and background so that I can personalize my agent based on that. So give me 5 of those preferences. And those preferences I will then load and append into the messages. And this way, now my agent knows or has some context about what does the user prefer, right? And the second event that I'm going to add is on the message added event. So every time a new message is added, be it tool message, be it user message, be it agent message, anytime a new message is added to the state, it is going to load the last message, and it's going to add that message. It's going to add that message into the memory session manager. So it's going to send it to agent core memory as a conversational message. So it's going to take in a message content, which is going to be the string, the question, or the content that the user provides, and along with the message role. So that's what we are sending to short-term memory for it to be processed for long-term.
How does it parse or differentiate between the user preferences versus the actual conversation?
So this you have to define. So for example, here, what we are doing is, in this case, we are adding it into the system prompt, right? The user preferences, we are adding in the system prompt. You can add it as a new message as well. And there you can write, literally in a string message, you can say, these are my user preferences. So it cannot literally separate between, oh, this is memory or this is a user message, but you have to define that on how you want to send it to the agent.
And the nice thing about this is that we give you the tools, and we give you the flexibility on using those tools for your use case, right?
Yeah.
I'm pretty sure everyone here has a different use case, and they're going to be able to interact with memory in a different way than the person that's sitting next to you, right?
There's a lot of sensitivity with data, especially
Yeah.
customer data. They always talk about data privacy, about sessions, long.
You have to decrypt it and retrieve it. That's how you protect it.
So are you worried that some people have access to other people's information? Yeah, we'll get to that. We'll get to that. Yeah. So right now, when you're sending messages to the short-term memory, you're defining an actor ID and a session ID, right? So with that actor ID, you can actually define who does that event belong to, right? So you have that logical separation in that way. And also you have IAM policies that you can apply, which contain conditions. So then you can give permissions to an agent to only access a memory resource if the actor ID is corresponding to whatever you say, right? So you have multiple ways of securing this. Yeah, but I'll cover it later. Yeah.
All right. So now we have created the hooks. And now the only thing we have to do is to register those hooks with the hook registry so that the agent knows that these are the callbacks that I have to do every time an agent is initialized or a message is added, right? So you add that into the hook registry. So now that is done. So we have now a way to call our memory, right? And we've also already defined a way to call our knowledge base. So now we're going to initialize the class for the hook provider, and we're going to add that to the agent. So we have defined the memory hooks, and we're going to add that to the agent, along with the tool that we created for searching the reinvent sessions for the knowledge base, right? And on top of that, we provide a state. So this is where we are giving it, in a more deterministic way, we are giving it the actor ID and the session ID. So this ideally should come from the application. Once the user has been authenticated, you get the user information from that session and provide the actor ID based on that. And similarly, create a new session ID or get it from whichever environment it's running in. But that you pass in as a state, so to make it more deterministic and to make sure that it's the same information that is propagated within the agent.
Yeah, you basically don't want to say to the agent, hey, this is the user, blah, 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 and this is your session, blah, 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 because it will probably hallucinate and it won't go away, right? You want to pass that as part of the application code.
Exactly. All right. So now we have the agent ready. Now we can test it, right? So first thing we do is to give it some information, because right now we haven't talked to the agent, so it doesn't know anything about me. So I give I seed in some information about myself, saying my name is Alice, I'm a software engineer at Telcorp. And this ideally should be loaded in a more gradual way. So when you're actually building an application, this will be built over time, right? But in this case, for demo purposes, we are kind of loading in information at once. So now we send that event, we call the agent with this information, and the agent responds us back with, okay, nice to meet you, Alice. Thank you for telling me about yourself. And then behind the scenes, using the hooks, it should be able to store that information in the short-term memory. And then around about 30 seconds later, it should also be available in the long-term memory, right? So the next time we are calling the long-term memory records, we should be able to see what we have already fed in. So if we list now the long-term memory records from that certain prefix, it should be able to retrieve our preferences that we just sent in. So now the interesting thing to note here is it not just stores the preference, but it also stores the context, how it extracted that preference. So it says the context is that the user explicitly stated that they work as a software engineer at TechCorp. And that's why I extracted the preference that they work as a software engineer. So it kind of defines a more explicit, defines more proper reason of why this preference has been extracted. And based on that, it also creates the preference. And now you can use this information across sessions. So if you create a new agent with a new session ID, with the same actor but different session ID, you are able to retrieve the same information about the actor, and you're able to use it within the question. So so I asked this question saying, hey, which sessions should I attend at reInvent, right? And I already mentioned that I'm interested in AI and security. So it responds me back with, based on it, I'm happy to help you with the perfect reinvent session. And based on your profile, I can see you're interested in cloud architecture, AI, and security, and that you prefer hands-on technical sessions. So let me give you some sessions, right? So based on that, it searches the reinvent sessions and gives me that based on your interest, these are the top recommendations that I'll say. So it gives me some Gen AI, some cloud operations, and some security recommendations, right? So it makes it more personalized for me of what I'm interested in, what's my profile, and based on that, it responds. So now we know that our memory is working. Let's move to runtime, right? So we now have the agent running in our local environment. How do we move this to production? So we need something that is giving us a session-level isolation, because, as you said, we are dealing with user data here, right? So we have to be highly vigilant on how we are deploying this. So the session not just has to be isolated on the compute level, but on the memory and the storage level. So this provides us, Agent Core Runtime provides us with true session isolation. So with the compute, memory, and storage. And it provides us with a fully enterprise-ready production workload-ready system. And it is automatically scalable, so it's a serverless setup which allows us to run hundreds of sessions in a parallel manner. So now how do we add this to the solution, right? So we have the endpoint that we created, so everything else remains the same. We are going to deploy this to Agent Core Runtime, right? So this is going to be our way to run this in production. So how does that work? So first of all, what we have created right now is we have an agent with any model, any framework. So we chose our bets. But you can bring in any model, any framework of your preference. And then what we're going to do is to create 2 endpoints for ping and for invocations. Ping we use for health checks, and invocations we would use to know where the entry point is. So how do I invoke? And then we add a requirements file, which defines what dependencies do we have to install. Now, that will be what defines our agent. So the first thing we have to do is to deploy that or to push that in a more packaged way to the ECR. So ECR, once we have pushed the code to ECR, we will have our container image ready, and we will provide some more configurations, like we will provide the protocol settings, like which protocol do I want to use, HTTP, A2A, MCP, how do I want to configure that agent. And we provide some network settings, and that's what completes our configuration setup. Now, once we have that, we're going to deploy that to Agent Core Runtime. And then we have our agent ready for invocation. So then we can, in a concurrent way, we can invoke multiple sessions from the application that we build.
And each session is a micro VM that spins up, loads that agent code, and you have a user that's going to be interacting with that specific agent via session ID. And when that session finishes, the micro VM gets shut down and everything gets deleted.
Yeah.
Right? So that's why we have to persist the information somewhere else, because when the Agent Core Runtime session finishes, the context that the agent has is gone.
Yeah. All right. So how do we prepare it for Agent Core Runtime? How do we prepare the agent that we created right now to deploy it under Agent Core Runtime? So we literally have to add 4 extra lines of code. So except the structuring of the code, we have to add 4 lines to make it ready for runtime. So first thing we add is importing the Agent Core application, right? And the second thing, we initialize the app. Now, the rest of the code is more about, it's the same things that we already created in the notebook previously. So we created a hook provider. We created a tool for searching the reinvent session. We create an initialize agent, which is doing the exact same thing as we did above. So it's importing the tools, hooks, and adding the actor ID, session ID as state. So we just package it into a function. And then we create a entry point. So this is the line number 3 of the code that we have to add. So we create this decorator to define that this is going to be the entry point of the application. And here we've taken a payload of whatever the user passes in from the application, from the front end. So that let's say gets in a prompt and the actor ID, which is going to be done after authentication. And then that is what goes in, initializes the agent, takes in the user input, and gives a response, right? And then finally, you have to run the application. So this is line number 4. So that is it. So this is what you have to add to make it ready. So essentially creating something like a fast API server that allows us to run this piece of code. Then we create an execution role, and then we configure and launch. So these are the 2 things we have to do to get it ready as an endpoint that is ready for consumption, essentially, for different users. So we have this Agent Core Starter Toolkit provides us with some tools to do that. So we have a .configure. So first of all, we configure the application with an execution role. We allow it to auto-create the ECR, provide a requirements file, and ask it to take in the agent and basically configure based on that. Now, once it has configured it, it creates a Docker file for you. If you want to customize that, you can create your own Docker file, or you can also provide your own endpoint from a different registry, essentially. Then once you have that, then you can call .launch, which is going to launch the application and put it for you to warm start, right? And here you can also provide some environment variables, which takes in your memory ID, knowledge base ID, model ID, and region. And now we have it up and running. So this will take around about a couple of minutes for you to get started. So now I think the only thing missing here, Danny, is the identity.
Yeah.
Do you want to add that?
Just show a small invocation to see how it looks like.
OK.
Yeah.
Makes sense.
So basically, we just pass from our local notebook where we have our POC working, we wowed our managers, and now we need to get this into production, right? So that's where we use Agent Core Runtime. We pass from a notebook to actually having our agents running at scale securely. And Akash, if you want to show how the invocation looks like,
yeah.
You can see there it says Agent Core Runtime.invoke. I'm passing in my prompt. What sessions would you recommend? And in this case, I'm passing my actor ID, right? This, remember, right now is hard-coded. The goal is not to have this hard-coded. It should actually know who the actor is based on our login. Okay, so if you see there,
So we asked the same question, what sessions would you recommend?
Exactly, and
as it already, more personalized recommendations to us.
Yeah, okay, so that's basically our agent running in Agent Core Runtime. Last bit of the architecture is identity, right? So here's where we use Agent Core Identity. How is this going to help us? Well, initially, we're going to have our user, which interacts with our application, right? First step, our user logs into application using our IDP of choice, right? We support multiple IDPs, right? Our user logs in, gets back an IDP token from that IDP, and then I can go and invoke Agent Core Runtime, right? So to that call that Akash had before, I will have a new variable that will say bearer token, right? And there I will include the IDP token that I got back from my IDP. Now, thanks to Agent Core Identity, inbound authentication, so basically it determines who the user is and if it's allowed to call the agent. Every time we call Agent Core Runtime, before it actually does the invocation, it will go call Agent Core Identity. Identity will go back to the IDP and validate that IDP token, okay? And if that's valid, it will say, hey, you're allowed to go ahead and do that invocation, okay? Pretty simple steps here. So how does that change at the code level? When we're doing in the agent core runtime configuration, we're going to add two different things. One is the authorizer configuration. That's where we are configuring our JWT authorizer. In this case, I'm using Cognito. So I'm passing in my discovery URL and my allowed clients, right? And also, very important bit here is my request header allow list. And what I'm doing here is that I'm allowing agent core runtime to propagate to the agent code the authorization token, right? So what's going to happen next inside the agent, if I show this here, is that when my user logs it, huh?
Let's see it here.
Okay.
I think.
When my user logs into the application, it will retrieve that identity token from Cognito. It will do the agent invocation, passing in that Cognito identity token. And from inside the agent, I'm calling Cognito with that token to retrieve the user information, right? And that's what the Akash is showing there.
So the same code that I showed before, it's the exact same functionality. The only thing that different is instead of passing in the actor ID directly, we are getting the user identity from the authorization header. So this is what is being propagated from the agent core runtime, and this is being authorized from agent core identity by Cognito.
Exactly. So no more hard coding either sessions or actor ID. The actor ID is coming straight from the identity token from Cognito. Session ID, we're using the same session that agent core runtime is running, right? So as you remember before, it works with sessions. Each session is a micro VM that's spun up, loads the agent code, and runs. That session has an ID, and that's what we're using as an ID for our session inside agent core memory. Right, and I think
that is it.
With 4 minutes left, that's it.
And exactly what Dani showed on the screen. So when we are configuring it, we added these two configuration for JWT authorizer and the header configurations. So we have them here that allows it to know what is the discovery URL from where to authorize from, and what would be the client ID. So what would be the allowed clients for me. And that is it.
Cool.
Keeps it ready.
So let me just go back to my.
We have 5 minutes to take questions.
Yeah. Resources and questions. Just put your resources. Here we have some agentic AI resources to get started. Agentic AI. We have GitHub, Bedrock Agent Core samples. We'll be pushing the code episode this week there. So if you go to GitHub and say, Amazon Bedrock Agent Core samples on their memory, it should be there. And yeah, follow me on LinkedIn, and Akarsha will probably post it there also. Very important, please complete the session survey. 5 stars recommended, others are optional. And yeah, I'll take any questions now.
Yeah.
Thank you.